So to make this problem much easier to look at, we're going to start off by writing all of our numbers in our set in decimal form. So 1.3 is already given to us in decimal form. Same thing with 1.3 with the repeating decimal. We can write this as just 1.3 with the bar over 3. The square root of 5 is not in decimal form, and when we calculate it, we get our answer is 2.23607 with no repeating pattern, but continuing on. And 5.34 is already decimal form, negative 500, same thing. 1 2/3 is going to be written as 1.6 with a repeating decimal place. We underline these numbers too. Square root of 16 is equal to 4. 246 divided by 579 is equal to 0.42487, continuing on with no repeating pattern. And negative 20 over 5 is equal to negative 4. So we're going to start off with part A, listing our natural numbers. So natural numbers are any whole numbers with no decimal places that are positive. So we can look at our set and say 1.3 is not a whole number, neither is 1.3 with the repeating decimal place, neither is square root of 5, 5.34. Negative 500 is a whole number, but it is not positive, so it's not a natural number. 1 2/3 is a decimal. Square root of 16 is 4. It's a positive integer, so that is a natural number. 246 over 579 has a decimal, and negative 20 over 5 is negative 4. So that negative means it's not a natural number. Part B, our integers are whole numbers, like natural numbers, but they can be positive or negative. So we already know that square root of 16 is going to be an integer, since it's also a natural number. And going down our list of numbers, we can see in order on our list, 1.3 no, 1.32 no, square root of 5 no, 5.34 no. Negative 500 is a whole number. Even though it's negative, it's still a whole number, so it's an integer. And finally, negative 20 over 5 is equal to negative 4, which is a whole number and is an integer. And we can do part C and D at the same time, just listing the numbers in their respective spaces, because if a number is rational, then it's not irrational, and if a number is irrational, then it's not rational, but every number will be either rational or irrational. So we'll start with 1.3. 1.3 is a rational number because rational numbers are integers or numbers with decimals that are repeating or have a set number of decimals. So 1.3 has a finite number of decimals, so it's rational. 1.333 with the repeating decimal is also rational because although it continues on forever, it has a repeating pattern, so it makes it rational. Square root of 5 has a decimal, but it's not repeating. It has no pattern whatsoever, so that means that square root of 5 is an irrational number. 5.34 has 2 decimal places that are set. They're finite, so 5.34 is a rational number. Negative 500 is an integer, so that means that it's a rational number. 1 2/3 has the repeating decimal place again, so 1 2/3 is also a rational number. Square root of 16, which we said is equal to 4, is an integer and is a rational number. 246 over 579, when we calculated it, we found that it does not have a repeating decimal, so it's irrational. 0.42, which is equal to 246 over 579 is an irrational number. And finally, negative 20 over 5 is negative 4, which is an integer and is also a rational number. And there are our solutions.